Okay, so we're going to get into videos now with projectile motion still, but now the object is going to be shot upward. So this could be like kicking a football, it could be like shooting a cannon up in the air, that type of thing. And pretty much what we're saying here, I'll just kind of show you the picture over here. On your copy, you have this picture too. And if you want to draw along with me, that would probably be a good idea. But what I'm going to do is show, okay, so we got something that is going to be shot, let's say, with an initial velocity of something like that. So that kind of shows you like an arrow like that. The only problem is like when it says initial velocity, this thing's on an angle. So this is like our velocity v. And like I've said before in physics, we don't really like things on angles. They're kind of, because the motion of this thing right now, it's gonna like, is it accelerating in that way, or is it moving at constant velocity? Well, part of it's moving at a constant velocity. The x part of it's moving at a constant velocity, but the y part is accelerating. It's accelerating at negative 9.81. So we want to split this thing up into its x component and its y component. So if I split this thing up into its x and its y component, then the y component here, this is going to be our vi in the y direction, and this is going to be our vx, and it's constant velocity, so it's not vi or vf or anything like that. So that's going to be pretty much the only difficult or more difficult problem or part of this now, is that we just split up that initial velocity. And that's pretty much what I have down here. So step number one in these type of problems is you got to split up that initial velocity of the ball you kicked or whatever it was. All right, so example 2, the ball is projected at an angle of 37 degrees up from the horizontal with a speed of 20 meters per second. I got to split this up. What was the maximum height? So again, what we're going to do is, we're going to do all these things, but I just like the table. So I'm going to do the table again over on the side. So we're going to say, we're going to split this up into its x and its y. So the x is only going to have three things it could be: vx, dx, and t. In the y direction, it can have all those acceleration ones. So we're going to have viy, vfy, t, a, and dy. And then I start filling in what I know. So as of right now, I don't know my vx, right? Because this 20 meters per second, that was on the angle. That was that, right? So what I got to do first is split that angle up into its x and its y components. And that's what was done over here. So vx, if you just figure out, you go 20 meters per second times cosine 30, using your trig identities. Vx is 15.97 meters per second. That's going to be constant throughout the entire trip, right? X direction is constant. Vy, and then I'm not sure why this says Vyo. I would call it Vyi for initial. So that's like our initial velocity. So just using the sine trig identity there. And that's 12.04 meters per second. So that's the initial velocity. And it's positive because it's going up. Okay, what else do we know? We know that, well, we know A is equal to negative 9.81 meters per second. And it says, what was the maximum height? So we're looking for dy. So that's what we're looking for. So it looks like I need one more thing if I'm going to figure that out in the y side, right? Well, we do know one more thing. Remember in lesson 9, I think it was, that when you threw something straight up in the air, it had to come to a stop before it came back down again, right? So in that case, VF was equal to 0. That's going to be the same case for when something is going on an angle like that. But at the very peak of this thing, VF in the y direction is going to be equal to 0. This thing is still moving at that point. The velocity is going to be 15.93. That's in the x direction at that point, but it's all horizontally. In the y direction, the velocity of this thing is 0. it had to come to a stop in the y direction before it could come back down. So hopefully that made sense. But anyway, that was the key bit of missing info there. So that's equal to 0. So now we're looking for d. So I'm going to use the formula that doesn't even have t in it, right? Because that's the one I don't really care about. So that's going to be Vf squared is equal to Vi squared plus 2AD. So d, if you rearrange that and put your numbers into it, I'll let you guys go ahead and do that. But if you put all your numbers into that, you get 7.4 meters if you rearrange and look for that. Okay, so that's d. The second part says how long was the ball in the air. So for that one, I just need to use a different formula. So I'll use a different color too. So for that one, we're looking for time. We got a few options now. I'm going to use this one. A is equal to Vf minus Vi over t, and rearrange it for t. If you do that, t would end up being equal to 1.23 seconds. But the question says, how long was the ball in the air? Can anyone see where I made a mistake here? Well, I said Vf was equal to 0, so the time I found was just from when this thing was kicked and then up to the peak where Vf was equal to 0. The question asked me how long was it in the air. So just like we're doing in lesson 9, when things were just going straight up and straight down, we need to multiply this by 2. So the time is going to be equal to 2.45 seconds. All right, now C says, what is the range? Now this is just a term that we need to kind of get straight. Range is the distance from there to there. I don't know if you play any kind of like video games with like shooting or anything. They might say that, like, those tanks are out of range. They're too far, or like a ship is shooting at another ship, and you say, oh, they're out of range. It's talking about a distance in the x direction. You might get a little confused by that because in math we talk about the range as being the y direction. If we're talking about like what is x allowed to be, or what is y allowed to be, sorry, in math, we call range up and down. So in physics, though, just to be confusing, we call range the distance in the x direction that something's going. So we're looking for dx now. So dx, that's this one here. The way we do that is we figured out the time was 2.45 seconds. Well, that's the same for both, for the x and y, so that's going to be 2.45 seconds. Now I just need to use my v is equal to d over t. So vx is equal to dx over t. If you solve for dx there, you get 39.2. But make sure when you do that, you were using Vx, right? You're 15.93, so in the x direction. Okay, hopefully that made sense, and I'll go through well, actually here, I forgot about the projectile problem. So what I have here with projectile problems is just some things to remember. So if you have to break it up into its x and y components, you have to know that horizontal and vertical components are independent. One's accelerating, one's moving at a constant velocity. The time that the projectile is in the air is going to be the same for the x direction and the y direction. So for most of these questions, we're going to make our we're going to make our table with x and y. And for the most part, we're going to find time first, and that's going to be the same for both. And then we're going to use that to solve the other one. That's the general trend of these. And then the last thing to remember, when it says range, it's talking about dx. Okay, example 3. A rock is thrown at a speed of 30 meters per second at 30 degrees below the horizontal from a 150 meter sheer cliff. How far away from the base of the cliff did the rock land? So we just got to do the same thing for this one, just knowing that the initial velocity, it's saying it's 30 degrees below the horizontal. We got to split it up, but just make sure you call v1 negative 15.0 meters per second. because it needs to go in as a negative into your formulas to give you the right answer. So then, yeah, pretty much just like the last one. So I won't go too much into that one. Make sure that your distance is going to be -2 because it's below you. But I'm going to leave that. You can go through that one on your own. Okay, that's it for that one. I'll go through the practice problems in the next video.